this video, we're going to look at solving radical equations that have extraneous solutions. So again, there is a certain domain that even number radicals can reside in. And when they go out of that domain, we start getting into complex numbers. So we're going to look at a couple of examples of where our solution will produce that complex number. So we're going to solve the radical equation. So the first one we're going to look at, get some yellow here. Give me 1 second. Let me change the color. All right. So the first one we're going to look at is going to be the square root. Again, this is an even index, an even radical. 3x minus 2 equals x minus 4. Okay, so the first thing I really want to do, the first thing that I want to look at is to isolate my radical, and that goes all the way over. My radical is isolated, so we're good. We already start out where we need to be. So the next thing I'm going to do is I'm going to square both sides. So now I have 3x minus 2. And this one, remember that this one is actually two binomials being multiplied together. So we have x minus 4 times x minus 4. All right, I'm just going to clean this up. I'm going to make this x squared minus 8x plus 16. And the reason I did that, the way I did that so fast is I did negative 4 plus negative 4. Because remember b, well, let me just do it like this. B plus c equals, let me get my eraser really fast. Oh, that's not an eraser. So remember that when we're looking at x plus, I don't know, x plus, I'm going to choose m times x plus n. B in the x squared plus bx plus c formula is going to equal m plus n, and c is going to equal m times n. So that's all I did. I did negative 4 plus negative 4 gave me negative 8. Negative 4 times negative 4 gave me a positive 16. So that's kind of a quicker way to do FOIL if you have nice clean binomials. All right, so now we're dealing with a quadratic, and with a quadratic, we need this to be equal to 0. So what I'm going to do next is I'm going to basically move the left side over to the right side by subtracting 3x and adding 2. So I'll subtract 3x, add 2, and we get 0 equals x squared minus 8, 9, 10, 11x plus 18. Right, I'm going to think of the two numbers again using this c equals m times n plus n to find b. So I'm thinking of two factors that will multiply to give me c, but add to get me b. And the two factors I come up with are x, 2x and 9. I have a negative here and a positive here, so negative times a negative gives me the positive, negative plus a negative gives me the negative there. So my solutions in this case are x equals 9 and x equals 2. Now, like I said before, let's substitute it back in. So I'm going to substitute x equals 9. We'll start with x equals 9 first. So we have the root of 3 times 9 minus 2 equals 9 minus 4. All right, 3 times 9, that is going to be 27 minus 2, 27, 26, 25 equals 5, and that is true. 5 does equal 5. We're good there. Now I'm going to try the second one, x equals 2. Well, we're going to look at the root of 3 times 2, which is 6. Oh no, yeah, 3 times 2, which is 6, minus 2, which then equals, we're doing 2, so 2 minus 4. Well, on this side, we're actually going to get a negative 2. And if you remember, for the domain of a square root, we cannot equal a negative. It's just, it can't quite really be there if you're just looking at a radicand inside the radical. So, and 6 minus 2 is going to be 4. 2 does not equal negative 2. So this one, x equals 2 is my extraneous solution. So 2 cannot equal negative 2. All right, so now this is an example of that extraneous solution. So let's look at another one. And I noticed that my word went down. I think I hit the right key. All right. So that was A. Let's look at B. B has the root of 3x minus 2 equals x minus 4. So x equals 2 is an extraneous solution of this. Why does the extraneous solution arise? So we have this. We know that x is a solution, but when we plug it in, this is now an extraneous solution. That means when we did the actual composition, we did find 2 was a solution, but when we substituted it back in, we found that it cannot actually be the solution. So this means that the equation of 3x, so when we did solve this, and this is what they're getting at. So when we did solve this, we found that we took the square root, so we know that the equation 3x minus 2 the square root equals x minus 4 is not equivalent to 3x minus 2 squared equals x minus 4 squared. And if we were to graph this, both graphs have an intersection at x equals 9, but the second graph also has an intersection. This second graph, if I were to graph this one, this would have an intersection at x equals 9 and x equals 2. But this graph would only have an intersection at x equals 9. Squaring both sides of the original equation created an extraneous solution. So doing that squared on both sides is the thing that gave us that extraneous solution. Doing this first step in eliminating or getting rid of the square root is the thing that gave us this extraneous solution. So x equals 2 only works for an equation that is squared on both sides. So there we go. Extraneous solutions. We've seen them before for rationals, and now we're seeing them for radicals. All right, I will see you in the next video.